Okay, so we are about to look into factoring by grouping. So factoring by grouping is another form of factoring. So first we have factoring out the GCF. Now we have factoring by grouping. So this is a method, okay? So when you factor by grouping, you're going to always factor by grouping when there are four terms present. So in your directions will usually tell you to factor by grouping. But sometimes, like on this sheet, it just says to factor. You have to know that that means because you see four terms, you're going to have to use this method to factor the problem. Again, vocabulary is important. You have to learn your process and know what to do when. So four terms, we factor by grouping. So what you do, these are our steps. But before we get to that, I just want to look at some greatest common factor problems first, and then we're going to go back to the factoring by grouping. So let's look at this one, XA plus YA. So if we were factoring out the greatest common factor here, the greatest common factor would be A. So when we factor that A out, that would leave us with an X plus Y, right? We should be good and understand that. All right, on the next one, we have X times A plus B plus Y times A plus B. So when we look at this problem, what do we see as the GCF that's present? Well, you have two terms. X times A plus B is one term, and then Y times A plus B is a second term. Terms are separated by plus and minus signs, right? So each term both contains an A plus B. So that is the greatest common factor. So what do? We do just like we did on the other problem. I had an A. I wrote it on the outside of the parentheses. I have a common A plus B. I'm going to write it on the outside of a set of parentheses. And then what's left? The two lonely people sitting out here combine into their own set of parentheses, just like they did over here. Okay? Remember, it's about a process, not a problem. So focus on the method, not the problem type per se. Okay? So 2x times y minus 4 minus 3 times y minus 4. So GCF, I see common y minus 4. So I would pull that out. And then I would combine 2x minus 3. Okay? So we do all that. And we're going to use that as we move forward into factoring by grouping. Okay, so on this first example, we have 5x squared plus 25x plus 3xy plus 15y. It's four terms, so I know that I have to use factoring by grouping. So the first step says we're going to split into two groups. So you split them in half, essentially. Okay, you split them in half. So the first two terms and then the second two terms. Remember this plus sign here in front of 3xy, that belongs to him. So make sure you always split it before that sign. So the next step says factor out the greatest common factor from each group. So you have two groups, mind you, factoring by grouping. Okay, so you create groups. There we go. So in the first group, we are looking for a greatest common factor. So when I look at my terms, I have a 5x squared and a 25x. So we deal with our coefficients, then we should deal with the variable components. So the GCF for 5 and 25 would be a 5. All right, then we have x squared and x. So the GCF there would be x, right? Because we know the GCF for the variables is always just the one with the smallest exponent. So if we're factoring out 5x, what does that mean? It means we are really just dividing by that 5x, right? So it's just you're factoring out the GCF process, but you're going to do it twice in one problem, maybe 3 times, okay? So when we factor this, we would be left with x plus 5. So then when we look at our next set of parentheses, we have a 3xy plus a 15y. So first of all, the sign here of the leading term in this second set is going to come down as your GCF sign. So whatever the sign is of this first term for your second group, that's going to be the sign of your greatest common factor. It's important for you to know that. So when we look at this, we have 3xy and 15y. So our GCF would be 3y. So when we factor out that 3y, what does that mean? It means we will be left with an x plus 5. And when we look at what we have x plus 5 and x plus 5. We have a GCF present. So when you're factoring by grouping, when you factor out the GCF for each group, whatever is left in the parentheses should be the same. If they're not the same, you made a mistake or it's not factorable. Okay? So we pull out a single x plus 5, right? GCF, and then we group together the two lonely people outside. And that is factoring by grouping. All right, the next one, 12x cubed plus 20x squared plus 15x plus 25. We split it, and we do the GCF for each group. So in my first group, the GCF for 12 and 20, 4, x cubed and x squared, x squared. So when I factor that out, I'm going to end up with 3x plus 5. Then in my second group, I'm going to bring my plus sign down. And then I'm going to do GCF for 15 and 25 is 5. They both do not have an x, therefore I cannot factor out an x. So when I divide that out, I'm left with 3x plus 5. And I knew that's what I wanted because I'm very confident that I factored the first group correct. And I also know that in order for me to do this correctly, to factor by grouping, the parentheses must match here. So now I'm going to factor out a 3x plus 5 and combine together the 4x squared plus 5. And that is the end of our problem. And those are factored by grouping.